All right, I'm gonna hit up my social media here. I let my friends know I'm firing up this stream. But yeah, I've been kind of, I don't know, vaguely interested in the VTuber stuff. I'm like the technology behind it because I saw the animations and I saw what people were creating, and it was really impressive to me to some on some level. I thought, man, I would love to learn how those algorithms worked. And so what I'm doing in the stream today is I'm going to go over what I can figure out to generate something similar to it to sort of understand how it works. I have a copy of um, the Cubism 4 editor installed as well, so I can kind of compare how it functions to like what it's actually being done in the warps. And this is more just kind of at the moment exploring the math behind it and some of the process. And I am by no means a PhD. You're not going to see the world's most amazing math. I'm going to use shortcuts and I'm going to use quick hacky things, but it'll be black boxed and sort of organized in such a way that when I do find better algorithms, I should be able to replace them just fine. And let's see if I can get... What is... Okay, continue. I have to hit this button. Man, focus control is out of... It is not happy. Okay, I don't know what's going on. That did not kill it. Okay. That solves that problem. All right, so the general gist of what's going on here, I have a little bit of a test program. This is sort of a little sandbox environment. This is all in Python at the moment. Like I said, I'm maybe going to be porting this over to a Godot extension so that, or maybe even implement it as a Godot feature. I think that's my real interest long term. I don't know how to do that yet, but for the moment, what this tool does is just kind of renders it renders the actual Bezier curve just on the screen. And this one right now is set to render 10 control points or 10 segments within the Bezier curve. You can see here, and down here I can adjust, say I want 50 to get a little smoother curve, and I can launch it with 50. So we get 50 out of it. I'll probably port it also to, whenever I figure out how this works, I'll port this stuff into JavaScript as well. I may do that sooner rather than later, mostly because I just prefer writing the UI in JavaScript for the most part. And hopefully I can maintain it paying attention to chat. Just in case someone decides to actually join me here. I'm gonna spam my entire Twitch, sorry, all my Discord friends and everybody I can think of. Working on it. Oh, I'll do that too. Okay, I've just spammed like a bajillion people. hopefully that works out. Probably get a bunch of annoyed people. Yeah, so the idea right now is I want to explore this how this VTuber scaling vector algorithm works, and so I'll go over the general gist of it. Let me launch this Cubism 4 editor, and uh, it does seem to work well in Wine. If anyone else was interested, I'm using Proton 5 with it right now. There is a there is a hey Ginger, nice to join. Thank you for showing up. Yeah, it'll hurt your brain, but I think you'll enjoy what the outcome is. I mean, this is probably honestly, right along your interests. As long as this stupid program launches, geez, take forever. So I don't know if you're familiar with the VTuber phenomenon. These tools to me seem a little abysmal, but so there's the people with the virtual avatars, kind of doing their thing, and I don't know, the animation technology. It just seemed interesting. Oh, did I just crash out? Oh wow, it is not happy today. This has been running great for like 4 days, and now it decides to crash out when I decide to do the stream. I'm gonna try to do it for around 2 hours, and give or take, maybe a little longer, and then I'll also upload a copy of it to the to YouTube, so there'll be an archive. Just kind of curious if people are, I don't know, interested in this sort of a thing. Well, if Cubism isn't going to launch, if the editor's not going to launch correctly, or it's going to keep crashing out, then I'll just have to use the Inkscape to demonstrate the thing. So I hit for some reason I can't click continue here. I have to close that, hit continue. Okay, there we go. Now it's loading. I don't want the new version. It don't matter. So there's a free Hiyori model that you can get, and this is so. For those who don't know what's going on, you basically have this editor tool that allows you to do some sort of pseudo 3D, like it's this 2D animation thing where you can define keyframes, and the keyframes adjust portions of the model so that the animation can be played. And a lot of people are hooking these up to live rigging so that they can actually act with these characters as their model. So you can go around and you can rotate, etc. So this looks like it's doing an eyebrow, eye ridge. This looks like it changes the center. I think, yeah, this is like her lean or tilt. And so this one's more interesting of a filter, because the lean or tilt, like notice how it changes multiple groups of the animation. So it's obviously attached to more than just, say, the torso. It affects the arm, and so there's some anchoring system. I don't understand that yet, but I want to figure out how that's going to work as well. But you can see how yeah, I have a little bit, because I'm really interested in this, like how it can be how the warping will, like how this all warps. So I'm going to write the algorithms. I sat there for like the whole day. I've been thinking about this, and yeah, yeah, I got a good idea how to do it. I'm not 100%, but Terrible, you were correct in your assessment that it is just purely two-dimensional, and I thought they were going to project these on 3D spaces. I would say that it reminds me very much like the Doom 2.5D versus 3D argument. Like, you design everything in 2 dimensions, and then you get a 3 dimensional like map generated from the settings. Like, even though they don't do it on a 3 dimensional plane, by doing so, if I find the head, it's this group here. No, it's one of these. It's this one. So this is her head tilt up and down like this. Well, when you think about it, when I rotate the head left or right, and if I'm the artist and I'm providing the perspective shift, I'm just not using 3 dimensional math to do it. I'm just sort of getting an intuition for it, right? So if I look up or down, you can see her chin changes size, and that's not really a perspective shift, but as an artist, it looks like a perspective shift. So I don't know. I'd argue that, yeah, it's still, that's why you can get that good 3D sense out of it. I like that. That's a little Arthur C. Clarke for us. Any sufficiently advanced 2D is indistinguishable from 3D. That's fair enough. Um, so if we can see the underlying mesh, there was a way I had this selected earlier where you could see the shape, and you can see how it warps the individual points. So if I look down here, how these are compressed in this, and then I look way up here, yeah, I wished. Oh yeah, no, I'm pretty sure Ginger Terrible's gonna totally set up his own waifu. Give it time. Give it time. Hell, give it time. He might ask you to puppeteer it for him. I need to somehow get the chat rigged to the recording too, because I'm recording it and I'll upload it to YouTube as well. But no one that watches the video will get the chat contents. All right, so the general gist right now, what I'm trying to figure out is like, I think I understand what's happening, and I want to describe it. So I have this little grid over here. It looks like there's two different planes, right, that get created. So there's a whole bunch of control points that get created, and the control points will just, that's close enough. These control points that get generated when you create your mesh overlay over your artwork. So your artwork gets a tri-mesh slapped over it, and that is how you control detail. So you can organize things like lines. And then you get another mesh, which is a grid for the warp grid that controls the resolution of the warping. And then a third mesh that is the layer that these blue nodes are at, that is the Bezier controls. So I can show that in the editor somehow. When you have it selected, right now you can see there's multiple nodes. There's a green one down here. You may not, I don't know if you can see it real well depending on compression. But there's a green control node down here. There's one towards the center, one up here, and one there. So this is a 2x4 Bezier control surface. And this is on the level, I think level 1 they call this. Oh no, level 1 is where you control that's just the overall scaling and shape of the, oops, I lost it. There's a way to lock these out so you're only controlling them. I still don't know the UI well enough. Yeah, you could compare this. So Ginger asked if it was similar to the avatar creating in Second Life, and I would say that it has similarities because you're gonna need to animate stuff. But again, this is mostly for 2D things. Although if I do get all this morphing and stuff figured out, I wonder if I could make a sort of like pseudo 2D 3D avatar you could wear as a Second Life skin. That'd be funny. Like whenever you face somebody, it would be your avatar and it would animate, but it would just be a three-dimensional surface with the two-dimensional texture slapped over it. It would look kind of dumb from any angle but forward, but Yeah, this is all pure two-dimension manipulation. That's what I was saying earlier. The fact that it looks like she's in 3 dimensions is just credit to the artist to envision what it looks like when this two-dimensional thing slides around. And then credit to the human brain because we probably fill in a lot of the gaps that would otherwise be dumb. Like some things I can notice that are very obvious when I'm looking at the details. Like you can see so she has a blush on her cheeks, right? Well, the blush on her cheeks is like very obviously squishing and an unnatural that would not happen. But you don't notice it because we're wired to ignore some details. And if it looks convincing enough, we'll believe it. So this is definitely going to be like the bare minimum first iteration stuff. Like you won't see any graphics. Like I'm not going to get to graphic level stuff yet. It'll take probably 2 or 3 sessions to get to real graphics. Right now I got to build the Bezier math stuff and then come up with the grid warping and how that all works and to understand it. I did a little bit of preliminary stuff so that it wasn't completely a nerd fest with just boring math, but at the same time, it's going to be a nerd fest with boring math. And I think I've even made the qualification early on that this is not going to be, I'm not going into calculus. I'm doing like estimations. I'm doing my best guess. So what I'm going to try to do right away is I'm going to set up this grid idea where I'm just going to create what we call the 2x2 Bezier control points. And in the system, there's a way to change this. There's a button. It's the create warp deformer. You pick the part and then you set the number of Bezier decisions here. So this one has Bezier divisions 2x3, and that's why it had the 2x3 cells. Why, if you came back down to it, you looked at it in number 2 mode. Is that right? Why am I not selecting this in number 2? There might be like another layer I'm missing to select this as correctly. So you can see there's a control point here, 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 which gives you this square here, a square here, and a square here. So it's 3 down and 2 across. And right now I'm not going to focus on too hard trying to figure out. I might just do the 1 by 1, like just what would it look like if I got a 1 by 1 that did this stuff, because it's all going to be a lot of brain melty. But I think what needs to happen is I need to take so let's build a little Bezier curve to kind of give a demonstration of what needs to happen. So we got a curve here. Whoops. So we'll curve this, and then from this point we'll do another curve. Whoops. Curve out this way. From this control point we'll do another curve out like this, and from this one to this one we'll curve out like this or something. I don't know. And the idea is that, whoops, hitting buttons. The idea here is that we have to build a virtual space. So this, I think what needs to happen is I generate a bunch of equidistant points across these lines, which I'm going to use an estimation technique for, because Bezier, I don't want to do calculus on stream. Why am I not in mode? There it goes. Stop drawing ovals. I don't need my Ovaltine. I need my circles. Somewhere down here was a corner. The idea is that it would subdivide this into its grid space just like it originally was, and these would all be equidistant points across these lines. And so I'm going to have keep dividing these up into approximately even arc lengths here. And so if this was this grid over here, and I had, say, a circle in this area, what's going to happen is I'm going to end up taking that circle and it's going to be projected, it's going to get skewed and warped in this corner. But this is also the same coordinate space as this grid here. So the idea that I have on this is that I have to build this this mesh that builds these coordinates, that maps the coordinates from this bent mesh into this, from this original mesh. Actually, it's more like this without these center control points. This is more like what we're generating. And so this is what I got to figure out on the math side of things. So that's what my goal is to kind of focus on that. So Bezier curves, when you generate them, they generate parametrically. So I'll show you how Bezier curves are generated. I think so a Bezier curve, we can actually draw it by hand quite easily. So I'll use this to draw some straight lines or semi-straight lines. We all did this when we were kids. You just didn't know it. I'm going to draw this line to here and then stop. And then I'm going to go a little down here and I'm going to draw this one to about the same distance here and stop. And I'm going to draw from here to here and then stop. And then I'm going to draw from around here to here and then stop. And then I'm going to draw this to this and then stop. And then this guy to this guy and stop. And dead. This is, I think, this is a quartic Bezier, or it's not a cubic Bezier, it's a straight Bezier. We've all kind of done this, I believe, when we were kids. I think this was a common thing to see in junior high and in notebooks everywhere. What the Bezier curve does, it's a more general mathematical form. It preserves from here to here. It preserves the actual the node. So if I were to pull this guy down here and this curve to how does this one? I don't remember how to make these map. I think it's 50% or cubic Beziers and whatever. But you can see how this is the general curve form, and so we need to calculate this general curve form using this as an algorithm, and that's what I'm doing. So I already have the algorithm that generates the two-dimensional points for the list of Bezier curves. You don't see it in here, but if you look real close, this line to this line is really long, this intersection. Then from here to here, it's a little shorter. And then from here to the, this is kind of goofy actually because I didn't set that right. But what you'll notice is that in these sharp turns, the number of line segments, they're just so much more shorter. And this is what happens in the real examples. So this doesn't give us what we call equidistant. I can't map this into some sort of a equidistant grid. So I need to come up with equal arc length set line segments on the Bezier curve. And because of the way it works mathematically, you don't get that naturally. You have to design it. And so I'm just going to do this terrible approximation. I'm going to calculate 1,000 points on the line. And then I'm going to do a line walk. Once I get 1,000 points, I'll calculate the length of the line. That's what this function's for right here. In this guy here. So this is the Python window generating it. I don't want to generate that code right now, or that screen right now. I want to display the actual. I want to just figure out what's the output is. So this has now generated a whole bunch of vec2d vectors on my output. What I need to do is now using these are my output points. So these are the Bezier points. I'm going to use calculate length. Do I have that? This is all, I'm doing this all in a Python 2 because the code that I had was originally, this is actually code I wrote a long time ago, actually probably like 6 years ago. And I just happened to have it and I didn't want to rewrite all the Bezier stuff, at least the original algorithm. I think the algorithm for the Bezier calc comes from a third party, but that's fine. I think I wrote the parts of the vec2d, but it doesn't look like my code exactly, so not 100% sure. So this shows the line lengths, and it's hard to really, let me probably zoom in a little bit for everybody. So this shows the line lengths, and you can see the initial when it launches. Let me do the drawing again. So if I draw it again, it's really hard to see in this, but the first line, it shoots up pretty straight, and then as the curve goes through, the lines get shorter and shorter because that's just how Beziers are calculated. You can see that the first line is 27, then it's 23, 22, 22, 22 until the curve finalizes over at 27. If I made these even shorter, you would probably even see it even more. Like if I made it like a 4 line, it would probably be pretty harsh. Yeah, it goes like 60, 54, 54, 60. So I need to get a sum of all these line lengths. So real simple. So now this will output the line length. So this is our approximation of that line length based on the number of points it generates. And you'll see that the precision's not terrible. So this is 4 control points. If I do 10 control points, it goes up. Yeah, it's a pretty good margin of error. What is that, around 2 to 4%, something like that, give or take. If I go up to 100 points, you'll see less of an error, right? So from 10 points to 100 points, we only gained about 0.5% precision, a little bit more. If I go to 1,000 points, you'll notice that going from the 100 to 1,000 points doesn't really get you a significant, and we're down into the differences in the thousandths of a number. So while this is not a perfect method, it's going to be within margins of error that's really easily manageable. And like, I don't mind calculating for 10,000 points if necessary. You'll notice that even with calculating at 10,000 individual line segments, I'm in the range of 10,000ths of a single unit or pixel. So given that most of these animations are on 10,000 by 10,000 art sheets and smaller, the margin of error is well within a pixel, so it'll be fine. So once I calculate the actual length of all these Bezier points, what I need to do is I need to build a walk, right? Because I need to gather all of the individual vertices that match what I would consider an estimated equidistant point along the line. There are algorithms to do equidistant Bezier stuff, but I didn't want to implement the algorithm on air. This is kind of easier to do, and I just wanted to get something out there. Let me see. All right, so this walk, this looks like this is correct. If I then go and I calculate for each one of the, I need to walk this this length across all of the points that are generated. So I probably want to send in the Bezier points, and I want to calculate. I want to do the calculate equidistant points. So print calculate equidistant points. So we'll do that. So I'm going to move this line length thing back to here. We don't really need it there. So we get the length, oops, equal to this thing, and then so I need to know how many segments we want in a line. So segments. So the number of segments I want will give me the number. It's +1 gives you the number of vertices you're going to generate. If I calculate length, so now I just basically say length divided by the number of segments. So this is the line length or segment length. And so then I just want to walk over all of the points. And while I'm walking over the points, I actually need to linearly interpolate each one of the line segments that I get. So if I do this with low quality, if I go, say, 10 points, and I have over here on a Bezier curve, I have 10 points. Let's do a little bit more aggressive, something like this. If I do equidistant points on this line, on this line, and you want an arc length of, say, 100 pixels, and that might be here in your program, but you might have crossed 3.5. I need to walk the individual line all the way up that point, and so that'll be the harder part to sort out. But what you do is you just you walk the line, so you know the number of segments you need. You know the starting point that you start at from the beginning, and so I would take each one of the segments. Now you can make 2 assumptions, and I might make the assumptions just for just for ease of like, building this out. So if the assumptions I make are that all of my points will always be smaller than my segment count, so that means I'll always have, at least 2 or 3 individual line segments, because I'm calculating 10,000 control lines. I can make the logic a little simpler here. So what I'll do is I'll iterate over each one of the line segments, and so this will be, I'll think this one through. I want to subtract, let me think. So I'm going to be walking the whole length, so the current position is going to be equal to 0. I'm going to iterate over each one of the segments, so each one of the points, and then I'm going to turn those into segments in range. Oops. Going to iterate over that. So this will then turn into a segment. The first point in the segment will be P1 is equal to points. This will be, let's just do I. This is I. Points I. P2 will be points I plus 1. Then I can do P2 minus P1, and I can do dot get length, which is the length of this individual line segment. I can say current pos is 0. I can say, trying to think how this is going to work. I want to make a collection of these points. I could do something terribly inefficient here that would make this actually probably really easy to code. Oh man. Everybody, maybe everyone's going to rage if anyone's paying attention. I can just make a function that returns back the exact point from origin to that. So what I can do is I can just request it 5 times, or if I divide this up 5 times, and then I'll get the linear curve length point on that, and I can come back and fix this later, so that I'm not like spending too much time. So the idea is that I want to get equidistant. I want to get a point at a distance. So calculate a point at, and I get the points, and then I say length right here, and this is going to be the curve length. So we'll call that curve length, and we're not going to worry about that anymore. And we're going to say current length or current position. Say current length. We'll just say curve length is this. So what I'll do is I'll just calculate the point at something. This is terribly inefficient. It's what is that? I can't think of the word for it, but yeah, it'll be fine. So what I'm doing now is I'm just searching for the individual line, the individual point interpolated over the curve, and then I can look up 5 of them. So obviously 0.0 is going to be 0.0. Let's see if I iterate over each one of these points, I get the length. What I want to determine is if the I'm going to say current length plus equals this right here. I know what we're doing. I just need this a trap. So I need to say if my length is less than current length, that means that we've actually found the line segment that goes past the length we're looking for. What I want to do then is I want to take the previous length. So I guess I do need the previous length. Previous length. And I want to subtract the previous length from the current length. I want to say, I could just do that the other way around. I could just subtract from the other end of that. I'll just keep going. We'll figure out what happens. So I'm going to calculate point at. I'm going to get the current length. So I need to interpolate over that line segment that I'm at, because obviously it's longer. And so what this is doing is, we got, if I go back over here, let's say we have a few line segments like this, and there's some arc, right? And that I've walked this arc. I'm searching for this point right here on the line. So I'm searching for this point, and I've actually found this point on the line. And so what I'm going to do is I'm going to say, oh, since I found this point on the line, and I know what point this is and this point is, I just need to then linearly interpolate from this distance. You subtract all these lines from it, and then you know approximately how far down that line I want to go. So I won't need this previous length because that's what, or will I? I will, because I need to be able, it's fine. Just going to do it. Okay, so I just say the interpolated length is going to be from current length minus previous length. No, it's going to be the current length minus, it's going to be previous length. It's going to be length minus previous length. So this is the amount that I need to walk over those the two vectors that are the two vectors that are the points for the line. And so what I need to do now is I'll just say I want to get points that are in the vector space of the two lines. So the coordinate space of these two line segments. So what I can do here is I have this point and I have this point, and I want to calculate between these two linearly to this. So what I'll do is I'll just take this this point here and I'll treat it like it's absolute zero. It's the center of the coordinate space, and I'll normalize this vector and multiply it times the leftover length I got here. So what I'll want to do we have a normalized? We do. Okay, so all I have to do is get this vector here, P2 minus P1. Let's see, is it get normalized or just normalized? It is normalized. Yep. Normalized. And then I want to just multiply it times that IL. This should give me the correctly projected point, so I should just be able to return from this. So now I'm going to figure out if this is correct, and so I'll come over here. And barring that I broke something utterly horribly, and if anybody wants to point out that I've broken something utterly horribly, I know there's a couple of people that are probably watching right now that want to speak out. Yes, I'm thinking of you. So I'm going to calculate the point at. I need to provide it the list of points in this in my calculated Bezier points. Do that, and we want to see the length of this, right? So I'm print the calculate length of Bezier points, right? It's just points. So I want to see the length of it real quick. I don't know what it is, so let's see what it is. 236. So let's calculate the point, a point that is 10 units down the line. Our control points are at 100 by 200. This is where it starts. This is where the curve casts up and over from. That's what we saw on the screen earlier. If I calculate something that's 10 units up, that shouldn't be, you're going to see a little bit of movement on the X, so it might be like 102, and I would anticipate that this would be like 190 something, around about that. So let's print out this thing and watch this break. Okay, calculate point as not defined. I got to import that. Bezier points is not defined. Probably did something silly down here. It's probably in here. I got a reference. It's this thing. Yeah. Do we need? I don't think we need this curve length anymore. Do we? No. Well, we probably need to calculate the curve length just to bail. But let's assume that we're not going to write this. We're going to write perfect code. So point is not defined. 43 points. That's what it is. Points. P1, P2 normalized, and count point at return. Unsupported operating times 4. Oh, so okay. So what's going on is I thought that this this normalized would take a single integer here, but it really isn't. It needs a vec2d. of just this by this. That's really all it needs. It doesn't have a... Oh. That's different. Is it? I'm reading this wrong. Oh, that's a freaking function, first of all. Then maybe that would have worked. Maybe that's what I did. Yeah, that's what I did wrong. Okay, so this is not what I would have anticipated. It's beautiful. It doesn't look off. Is it because I'm... Oh, yeah, I have to Okay, that's what I did. I have to re-add P1. P1. Yeah, see, it's about what I expected the number to be. So this looks like that kind of half-ass works. So, and I can explain what this is doing by actually drawing it now. So let's do back here to the original code that draws stuff. And I'm going to come up here somewhere in this code. Yeah, this looks like a good spot. Pos equals calculate point at. What this tool actually does, it's a little bit more than just drawing the curve. I was exploring whether or not my Bezier curve calculations was correct. That's what this tool is supposed to do, and I just wanted to be able to, like, I can just click new control points and it just adds new curves. So there's an extra code in this that kind of doesn't make a whole lot of sense, but you know, I'm like working around it, just getting. Got a sandbox, got to use it, right? Okay, so we're gonna calculate the point at. We're gonna do this pause. We're just gonna grab the control points from 0 to 4. So we're just gonna 0 to 4 like this, or 0 to 3. And this will be. Yeah, that should be right. And then we'll do. We'll say it's gonna be like 10 units up. And so now that I've got a position for that, there was something that drew circles. Yeah, here we go. Here's how you draw a circle. I have this position. Let me draw a circle on screen. Green selected 10. What is green screen selected 10? Selected .x, selected .y. Pygame, mouse kit pause. So this is a position. Must have an XY. That work? Integer argument expected. Got a float. Okay, let me look at the Pygame reference. One moment. Oh, I must have done something with my Chromium. I don't know what's going on. Okay, well, we'll look at the reference without live. Let's say Pygame. Okay, Pygame.draw.circle. Yeah, it's supposed to be center. So surface color. Oh, I know what I probably did wrong. It's this. No, green is correct. Selected. It just needs to be a. Can it be a float? What am I doing wrong here? It needs to be a Pygame. It can be a tuple. Enter float. Well, that's confusing. I should be able to calculate the pause. Yeah. So it can be a tuple or an array, so that's XY. I wouldn't imagine this being. And it's not really helping me here with this error. Okay, let me be. Okay, hold on. Hold on. Let's just go back to basics. Will it draw that? Yeah, it draws that just fine. Okay, that's what I would have expected. Also, I definitely don't need it that big. More like 4 pixels. There we go. So, okay. Screen. So print pause. This is gonna blast a whole bunch of pauses across the screen, but that's okay. So I get this Vec2D 100 by 190. But if I just turned it into... Oh, I'm being absolutely stupid. I know what's going on. God. It literally was just, it needs to cast. Because it doesn't expect these to be floating point values on a pixel screen. Duh. So we just... I wonder if that vector library has an int. No, but I might add that just because that probably is going to be really annoying. So yeah, now this should just draw correctly. Yeah, so you can see that I picked a line segment that is approximately 10 pixels above the center point there. And so now to get, like say 5 right across it, we would just do calculate, the grid mesh. We can just say, get the length. We'll divide that up in 10 segments, and then we'll calculate a few points. So let me calculate some equidistant points across all of the Bezier curves that we have here. So this is the loop that draws all the different curves in the tool. And I would like to do, we'll do that. We'll just call equidistant. We'll say points, segments like this. Then we want to get the curve length. The first points are obviously going to be 0.0. So we say curve length over segment. So the first and last point, I won't calculate those because they'll have a derived error, and those can actually, exacerbate error beyond the points. The control points should be considered constant positions, or the endpoints, I should say, should be considered constant, just in case you derive other mathematical primitives off of them. That, to me, that seems like a reasonable way to handle that. So if I come into the segment, the curve length, segment length, if I do this where I say points equals, so I'm going to calculate, I'm only going to, so if the number 5 comes in, I'm only going to calculate 3 points, right? So I need to do this, points equals, it's going to be an array, and it's going to be points 0. And then I'm going to say for s equals s in range 1 comma segments minus 2. And then I'm going to say points plus equals, and then we're going to do that really horribly dirty calculate point at function here. I'm going to pass it in the points, and I'm going to say the segment length times the current segment we're on. And then at the very end, I'm going to say points plus equals. Is this right? Hold on. Segments, it's always going to be, points is always going to be segments plus 1. So this should be correct. That's fine. We'll either see it in it'll get rendered wrong or it'll get rendered right. So this should just be points minus 1, and then return points. Return points. Wow, what a terribly inefficient way to calculate things, but it will work. So we will import this, and After importing it there, I will use it here. Equidistant, we'll have points equals equidistant Bezier points, comma, we'll say 5 segments for now, just to see what comes out of that. And then from there, I will say for points, point in points, point.x, point.y, and so now this should draw control point or little equidistant points for every one of the lines. Current length is not defined. Oh, that's curve length. None type an int. Oh, I did a breaky thing. Let's see. This is on line 126. Oh, I see what's going on. This is not, that's not what's broken. It's this right here. Line 47. Current length. So I think what's happening is I've exhausted the length of the number of points. There's no guards for that. No. Okay. Okay. We will just say this. S equals 1. Oh, what the hell was that? That's a weird... No attribute X. What? Okay, segment length, curve length, segments, points. I mean, it should be able to return a single point, right? Like, we know that this should be a thing. Yeah, so it starts out at the origin. Well, does it terminate at the last point? I should see a green sign, a green dot on the last point, which I don't see, which is interesting. Wait, why wouldn't it draw the last point? Did I just not run it? No. That's okay, that's confusing. Wait, am I passing the right stuff to it? Equidistant. Calculate Bezier. Yeah, that's correct. Unless, I mean, no, the draw points wouldn't do anything silly. All right, which one of you out there has figured out the problem already? What did I do wrong? So this should have worked. I should at least see 2 points. Okay. Yeah, that's even, oh, they're the same point. That doesn't make perfect sense. Oh my god, I'm a fucking moron. Jesus Christ. So Ginger just asked, did you draw a circle and the end point is the start, or did you just forget to change the color of the last point from blue? No, that is not the case, actually. I'm being absolutely stupid trying to code this thing without... I overwrote my freaking result value, and it was corrupting the whole entire concept of what we call, you know, being stateful. Jesus, that's going to be on the internet forever. Hope no future hiring manager sees that one. Yeah, there we go. Jesus. Yeah, and this was one like I thought. Although this is interesting. 1, 2, 3. We got 4 points. So maybe I do need to not do segment. I just do. Oh, right, because segment. Okay, that makes sense. So now it generates points that are sort of equidistant on the line segment. And then so for there, what I can do is, if I end up with, say, 4 of these Bezier line curves, I can then start drawing, say, a mesh across them, and then I can think of what the warping is. I'm pretty sure that all of the warping in the algorithms are linear warps. They're all linear blends. They don't do anything with high math. What they do is they use all of the higher order, the Bezier curves, they use the control nodes and all this other stuff to drive the linear texture mapping that you apply to the 2D texture. So if we go back to the live 2D, there's the Cubism Editor here. You'll see the grid that gets put over. So I'll grab her hair here, this piece. And whoops, I just grabbed a point. This editor is a little obtuse because you grab the wrong thing all the time. It is really annoying. This is probably one of the things I do when I build is like, if I get far enough along and trying to understand how this stuff works and like the blending, I'm going to build my own tool because I hate this tool. Like, Jesus, it's terrible. But it works great. Like, it's one of those things where it's like, it has grown, it has a life of its own. And yeah, I get it. Like, so, okay. When you define your image, right, you get this image here. And then what you'll do is you'll come through, and I don't know if this gets auto-meshed or if the artist comes in and just defines this stuff themselves. But, you generate these mesh, and this mesh draws the same triangle no matter what you do. So this is a linear warp. So if I stretch this out, this point here looks to be about halfway, this portion of the hair, the outline. If I move this here, it'll always be about the same halfway mark. So the triangle portions of the mesh don't do any sort of interpolation or smooth interpolation. There's no pixel shader that's calculating an infinite Bezier curve grid, which I thought about earlier, like that would be really clever, but I don't want to write that. I really don't want to write that shader. That'll hurt my brain. So what happens is once you get these anchor points and it draws the shape you like, or it covers the segment from your artwork, you get the various layers of editing over here. How do I change this? I thought you clicked this and it just changed. Oh, here's the mesh editor. So that, look, you can just change the points on the mesh. Probably drawing new ones if you wanted to as well. Yeah, that's nice. Oops. Oh, I probably shouldn't have clicked that. Oh, okay. This is all the random parts that belong to this character. And this is what you probably have to do in some step of this building this stuff. You have to like draw out all these individual pieces. I'm sure there are people watching this like, yeah, that's right. That's like, making it 101. I get it. That's the remedial level. But this is got a warp over the top of it, I think. And I don't know what half these buttons do. Oh, this one maybe didn't have a warp deformer on it. Maybe this one was only done with vertex editing. So like one of the other ways you can warp these is you can, as the animator, come in and say like, I just want to warp these things with, I want to manually draw it. And it looks like this does not actually change. So maybe they went in and manually, or this is a scaled warp. I see. They just use the scalar output here. They don't, there's no other crazy thing being done here. I see it now. So this doesn't have any other kind of, oh, I got a lot of stuff in my undo buffer. Put her hair back on. All right. One thing I know that does have a complex warp is the eyebrow. The eyebrow eyelid sort of area. This has a complex warp on it as that I saw. But again, actually, now that I think about it, that is down here, I think. No, that's the arm. Is it this one? No. It's something. Man. It's a button. Oh, wait, I'm in the wrong. How did I end up getting into the texture atlas? That's weird. Oh, I already found the eyes. Where's it at? That's this. Yeah. This one I think is doing a vertex. Like it's literally they bent the image into this shape. There's no Beziers around this. There's no warp mesh for that. But the faces seem to almost always use a warp because it tends to keep the center line really nice in perspective. You can draw it real well. And then you leave a lot of vertexes around these details like the lines so that you can align them a little better at the end destinations. But what I was getting at was that this is all linear interpolations. So the way this sets up, you set your keyframe points for the up, down, left, right areas here like this. But the individual vertices move as a linear warp based on this input signal. And if let me think through this here. So I'm pretty sure that you just set up your textures, set up your that texture matte, the outlines of all the parts, and then once you do that, you can set up these warpings. Then they all just sort of follow that linear path from the original thing. Eventually, I'll probably end up creating a small UI in React or something, and that way I can kind of get more into the UI, hooking up UI elements to this. Because writing a UI in Pygame would be, I don't want to write that on live. That would be abysmal, and just doesn't serve the end goal of trying to figure out how to build these things. But I do like Python for some quick prototyping of like bullshitty math stuff, just kind of figuring it out. So this thing, we have to go back into here. I want to see now, how would I create a grid? So I don't want to draw this main loop anymore. I want to do my own another loop here, and I want to create a Bezier curved grid. And the Bezier curved grid then also needs to be able to have a linearly interpolated point that I can drag around that Bezier grid. So what I mean by that is I want to have a control at some point where I have this point and I can drag it around. And as I drag it on this square, you'll watch how it moves across this curve at linear rates. It should deform correctly. That's the goal. And that way, then you have the ability to map from texture space into curve space, or the points that are on the texture mapped into the curve space to get the warping of the texture. And I think I'm going to use, I think my first iteration is going to be using Babylon.js. I just know it really well from another project I've been working on. And I'll probably implement all the warping stuff in that library first. I kind of think I'll plan on open sourcing most of this stuff, to be totally honest, just because I don't know if I'll go very far with it. We'll see. We have. So I want to generate a grid, right? So this is a Bezier grid. I need 4 control points. And I need them to be, I need 4 corner points and then 4 control points. So I kind of want to figure out what I might like to see on the screen, and I want something simple at first. So I kind of want something like this, and then I would say something like that there, and then I want to get the control points. Oops. So something like this, and I don't know if I even care if the rest of these had warps on them. But let me see what these control points look like when I select them. So let's imagine that this is my 0, 0 coordinate up top left here, or maybe this, and this is like my 10, 10 coordinate. That's a good, this is something about that. Maybe we'll make this 500 pixels wide. This will be about 100 pixels in, 100 pixels in on this one, like that. And then I'll do the same thing on the right side. I'll just set these coordinates to be this. Oops, whoop, this guy like this, and so we'll get like a little rounded warping grid, and then I'll figure out how to do other things with the control points, and then maybe I'll animate two different squares. One will have a sphere, or sorry, circle that just kind of goes in a around it in the square, but then we'll also map the circle's coordinates to this this coordinate space. So that'll be the end goal for that particular Bezier tile. So let me think through this. I need to create my control points. Let's start there. Or maybe I need to create this event loop. Just copy pasta some code over here and we'll iterate. So this will be line 1, line 2, line 3, line 4. Do I want to label them or put them in arrays? We'll just say lines. So these are my my input lines. Selected point. Now, part of me is wondering how this how to interpolate over this. One of the ways that we can interpolate, and this is where I start getting a little lost, and I'm like, do I get ahead of myself? I could either linearly interpolate from the selected control points, which I may do because it might just be easier overall and not be prone to that much error. And what I mean by that is I could have this control, these points that I've calculated equidistantly across this surface. And let's say that this curve on this line is actually the opposite. It goes in like this. That would mean that these control points get compressed in the middle, and they get obviously wider than the control points, but these coordinate points get wider on the outside, and that's kind of hard to see with that red background, I guess. And so you can see that they get skinnier towards the middle. I'm wondering if what I'll need to do is, do I produce, like this would probably be more like, well, actually, okay, that's where I'm going. I'm wrong here. Hold on. I'm doing this wrong. In the middle, it's literally just going to be straight up and down because, right, it's the blend between these two Bezier curve nodes. And I'm debating, because I know this will generate a very linear space between, say, these 4 nodes. I'm debating like what might be the way to do this right. Do I just calculate 1,000 of these particular nodes, and this grid is 1,000 by 1,000, very like slightly error prone coordinate spaces, but at the same time they're real easy to calculate. The numbers are all the numbers could be done with fixed pointers. The idea is that it's really fast but prone to error. And I suspect that's the way to go. I was looking at some of the other competitors, and they even advertised smaller and smaller mesh sizes because I think that's how everyone's doing this, is basically that. So I'm going to keep going with that assumption until it breaks, I think. Unless someone, tells me differently. So we have this thing. We don't care about mouse buttons in this loop. We don't care about button up. We do care about pressing escape. We do want to clear the screen. We don't care about selected. What we do care about is drawing these 4 lines. So these are control points, and these are the control lines, and these are the Bezier curves. So I need to go over for line in lines. So I want to draw all of my Bezier curves first. Let's get the coordinates set up for these things. Let's put this at 100 by 100. If that's the start point, I want this to be 110 by 110 here. Isn't this how this works? This is a control point, and then the end point. Yeah, that's how that works. So then this would be the other control point. I want this to be at, like, say, x is going to be 100, the y is going to be 500, and then the this would be x of 110 as well, but this would be 500 minus 10, so 490. Yep, I think that's right. So there's my one control line. Let's do that. Let's just do one control line and line and lines. Did I lose all that stuff? I did. That's fine. I was thinking about the way that I've got that calculate a point at a distance on the Bezier line, and it sort of already generates an infinite grid, so I could easily just take that and use that to calculate. No, it wouldn't calculate two curves, right? It would calculate this curve, but it wouldn't calculate, with this curve, so that would be... Oh man, we could actually use that on the subgrid. Okay, that's interesting. It's clicking. Some things are clicking for me here. We need to put this here. So we need to draw control points. This guy here, control points. For each one of these lines, this line is going to be this thing. So P in line, draw. Yep, that'll just give a blue point. And then for control lines, we want to draw. Okay, and this is just going to be line like this. And then we want to draw the Bezier curve. We don't need to do this, we just need to do this. This is just going to be line as well. And this is the resolution of the Bezier curve. Then we just say, hey, yeah, go ahead and draw these points in, draw the lines. And now I'm going to calculate across the equidistant points and then draw those. And that should be that, is hopefully, famous last words. This is also going to be changed to the Bezier Grid function. Oh, I'm still running. Oh, Jesus. That looks like it's drawing the correct stuff. So, but it's not a big enough differentiator because these are what is the resolution of this 400. So this needs to be more like 50, 50, 50, 50. Yeah, that's a better curve. Although I feel like it's not symmetrical or something. I don't know. That's fine. It's fine. So if I then do this here, where I draw from, let's see, 100, 200, then I'm going to go, my y is going to be basically 50, 50 again, but my x is going to become 500. My y is going to become, it's going to stay at 100. So this will be, wait, hold on. This is 150 to 1, oh, this needs to stay 100. 100, 150, 150 is fine. Then this is, this here is 500 by 100. So then the 500 by 50, so 450 here, and this would be 150. Yes. And so this would draw the top line. So now there's the top curve. This might not be the stuff I need to calculate in order to actually get an actual mesh of a character out. That's now that I think about this, but that's something's occurring to me that there might be a different way to write this now that I've kind of dove into it for a minute. But I'm going to keep going with this because I need to learn a little more about. I need to think more in this translation space. This is so I can figure out what I'm doing a little bit. So I want to be from the x coordinate is going to be 500, the y coordinate is going to be 100. Then this is going to be the x coordinate of 450, the y coordinate of 150, and this is going to be same x coordinate 450, but then also the y coordinate 450, while this becomes the x coordinate 500 and the y coordinate of 500. So that's the third line in our little thing. But this is kind of I want to draw it a little differently. I want to flip these around, I think. So I want this to be 550, 150, 550, 150. So now it just bows to the right. And I might make the bottom line bow up. Yeah, I'm not 100% sure how this is going to work because it's not. I think I'm thinking this a little wrongly, but that's all right. I'll suffer. 100 by 500. This one would be 550. 450 by 450. This one would be, no, that's not, that's 150 by 450. This is 450 by 450. Yeah. So the intent here would be that you would get, if I tried to plot along this point, it would be, or this would be a path that would curve all the way from here to here. And so it has to happen in order to do that is I either have to linearly interpolate. Oh yeah, I'd have to linearly interpolate my Bezier curves across all of these. I couldn't. There's no natural way to get the curve forms, which is not a problem. We can. So what that means is that I will take this point and this point, and I will say that I want to cross this equidistant grid. And I'm going to just say this is my new endpoints because I've calculated their equidistant position. I know then that this is some X percentage across this grid. I should be able to, let's see, I should be able to then just interpolate, whatever percentage this is over the line with both these control points, and then it should work. Plus or, so you also go down. Not 100%, but I'll just keep throwing numbers at it until things work. Isn't that how math works? Isn't that how you're supposed to do math? No arguments. All right. Well. So I suspect what I'll have to do eventually when I do come up with the mesh tooling. So the mesh tooling will fit on a rectilinear grid, and they'll be in a standard Cartesian grid, and then they'll be mapped to whatever I bend and warp it to. So it'll always start somewhere normalized, and then it'll get bent. So they don't have to think anything like crazy like that around. Let's see. So I guess next, what I really want to do is figure out how to calculate the grid. So I really need to think of that reference a little bit better. Let me actually do this. Oh, oops. That's not what I wanted. I will steal this little graphic and I will throw it into my little workspace over here. I think, there it goes. So this is going to be, so if I move control points, let me come up with this little bit here. So I got a control point that moves, or sorry, an endpoint that moves here. and that endpoint is here, that curve is going to have to follow some, sanity of the curve that it previously came from. It can't just be straight line. That would be not curving space, right? It wouldn't warp space. What I have to do is I warp space by interpolating the control points as well as the and so now I need to generate a Bezier curve that the control points that blend, say, so whatever percentage this is down with these control points. And I have to think about what that means. So I have to normalize, I guess I normalize this vector from the start point to this vector. And so if I just copied that here to there, that would be, close, but not right. It wouldn't be the correct answer. What I probably do is apply a little bit of this control points percentage into this one, I think. But I think that generates two different types of curves in this situation. I think this gets weird because I suspect, I wonder if it generates the exact same numbers if I walk this grid this direction or walk the grid this direction. But if I do it down, I'm going to generate 4 new Bezier curves down that blend control nodes. And if I had this, if this grid that I designed here was symmetrical, would it generate the same points? That's okay. I guess we'll find out. So in this scenario, I want to move whatever this percentage is down. So I need to come up with a way to calculate, blend the nodes. So I need to come up with a function to do that. And I need to think through that. So I'm going to blend the Bezier curves. So now I've got the fixed points. The fixed points that I have aren't stored in any array, so I don't have any information on what those points look like in my tooling here. So I honestly need to generate that stuff at the beginning. I don't want to generate it here. So I'm going to iterate over all the lines, and I'm going to say this is the I don't want to do that from each line. I think what I'll do is I'll calculate out these individual Bezier lines and just draw them and then see what happens. And hopefully they'll fit the curved space. Okay, so how I'm going to do that is I will calculate, I won't need, yes, I will. I'll need to calculate the Bezier points for the left and right lines. In this, this is the top. I think that's the top. No, this is 100 to 500. This is left. This is left. This is top. This is, let's see, X. This is right. And this must be bottom. Yes. So I need left and top. So that's lines 0 and 3. Lines 0, or sorry, I need left and right. Left is line 0, and then I say right. Two. Oh, it's not drawing anything because I removed all that code. Maybe I don't want to remove the code. Let's go back. If I'm going to split these equidistant points into 5 segments, did it cut into 5? 1, 2, 3, 4. It is 5 segments. There's no center line, which kind of bugs my brain for some reason. So it is 5 segments. That's a 25%, or sorry, a 20% increase down the line. I'll just hard code it since I'm not gonna. No big deal. So in order to interpolate the first Bezier line, the first Bezier line would be interpolated by taking left. We'll say P1 equals I almost just want to copy that, but we'll just say left 0, and this is C1, and this is C2. 1, 2, and left P2. So this is the left points. This is 2. This is 3. And so what this is the the start and end of the actual line that we're drawing, and then the curve control points that we draw through. And I'm breaking this all out just so that I can, think through things a little easier and not really hurt myself. So I want to calculate, I want to normalize the distance, this point here to this point. So you subtract it, and then I want to get the unit vector of this point to this point. And then I will interpolate it by averaging, let's see, I basically want, I see what I want. I want 20% of this normalized vector, and I want 80% of this normalized vector. That's what I want. Okay. So I want to create the new P1. The new P1 is going to be my control points. So I need to calculate those for left and right. So we have left and right lines. I want to calculate left points, and I want to say left EQ points like this. And so my new control line, my P0, is going to be, the new line is going to be left, it's going to be left EQ points 0, it's going to be 1. Because 0 is the original point on the line itself. Then I'm going to say, so once I get the line on, so what I'm getting here, let me think about this one a second. I'm getting this point. So if I grab my left points, this is the left vertical line, so that's this line here, and I grab the first element from it, that's this point, and this is the new, because we're going to draw this new curved horizontal line here, and so that means I need to say left EQ points, one. And then we have to generate the two control points, but the line obviously has control points that we could, for the moment, I could copy the control point just to get something to render, just so I can kind of, like sometimes a good quick win is nice in this situation, just so you're like not hurting yourself thinking through these things. So let's do that. Let me just copy the control points from the original line. So that's just going to be left C1, which wouldn't be the right control. No, that would be that's a terrible fucking idea. Whoever said that, to do that is an idiot. Because I wouldn't be able to get the exact, I would have to normalize them too, that just gets weirder. So my new control, my C1 is going to be basically 80% of the normalized vector of the P1 minus C1, so this is going to be left C1 minus left P1, right, dot get normalized, that's what it is, it's just normalized, so normalized. So I'm going to get 80% of this vector is now going to be added to my left. We have to interpolate the length of these two, because if the control points have different lengths, I'll have to interpolate from this to this. Interesting. This is all interesting. So I want to get this normalized. I want this to be, yeah, so we'll say 0.8 times this. And then I want to take, I don't know what to call these variables anymore. This is just A for now. And then B is going to be 20% of left control point 2, C2 minus 0.2 normalized. Now if I take these two vectors and then I want to also get the A length is equal to left C1 minus left P1 dot, I think this one was the get length. Oh, it's just self.length. Okay. Okay, just dot length. So dot length times 80%. And then B length times 20%. So that's C2, P2. And then once I get the two lengths, I now need to average the two vectors. I need to, because this one is, it is normalized, I could just say, yeah, I guess it's just A plus B over 2, 2.0. And then multiplied times A length plus B length over 2.0. I think this is the way to do that, right? Or is this, we'll see. We'll see. It'll either work or it won't. And unfortunately, that's just calculating the first control point. So this would be line C1 is now equal to, I think this is the vector, or the point. Oh, I need to add in my left EQ points 1 plus this monstrosity. So it's going to be these vectors added over 2, and I should probably, I don't know, order of operations in this situation, multiplied by the averaged lengths over 2. Oh, I could probably just multiply this whole thing and divide by 2. Whatever. So that'll give us C1. Now C2 is effectively the same thing with just the 80s and 20s honestly flipped, and then the positions flipped. Or no, if I just, yeah. So we want 20% of A and 80% of B, and we want 20% of A and 80% of B, and that is actually, this should be EQ points. It won't be 6, it will be 4? This is 0, 1, 2, 3, 4, 5. It's 4. Okay. So 4. Something like that. This is C2. And we'll just do this then. Line C1, line C2, then line EQ points, definitely not 1. This would be -1. Okay, so that calculates a single line. That is not right. I just did something really dumb. Okay, what I did is I need to apply the same math, not to this point, but to this point on the right side. So I got the right side that needs to be calculated because I'm drawing the line from left to right. I don't know why I just put the numbers in for the bottom to top. That's funny. And they would be absolutely the wrong numbers. So it's still going to be 80 and 20 and 80 and 20, but it's not going to be left C1. It's going to be right C1, and this is right C2 minus right P1, right P2, right P2. And then I gotta keep Gotta keep typing. I don't know why I stopped. Brain shut down for a second. Right P2, right P2. Okay, so line C2 is not right EQ, it's going to be, or left, it's going to be right EQ points 1 plus A OB divided by 2. So this now becomes line left EQ points 1, line C1, line C2, and then right EQ points 1. Oof. Okay, so now this is my new Bezier line that I can draw. So now, oh man, this is good stuff. I want to draw this one special, let's say. I want to calculate its points, and then we will draw its lines like this. So this is going to be new line. We'll just call it new line for now. And when I draw a new line, what did I pull out? I pulled this out here. New line is equal to, sorry, no, B points is equal, oh, Jesus, I'm deleting everything. This is new line. We're going to generate 50 points for it. Then we're just going to draw it in yellow. No yellow. Okay. Okay. We'll see what breaks. Let's see how this goes. Hey, it all breaks. Line reference before assignment. That's not a big deal. Bezier Grid line 50. 105. So that's because I'm looking at calculate. It's going to be lines 0. Oh no, I just put left here. I don't know why. Left points. Did I ever calculate right points? Or do I need to? Wait, I should have to because I need left EQ points. Oh, I don't even have a right EQ points. Oof. I need right points, left points, right EQ points. Calculate Bezier. Oh, this is all sorts of not coded right. Who wrote this shit? Well, it didn't crash. I mean, that's something, right? Okay. Hey, Somnam, how you doing? Excellent. I don't know how long you've been hanging out or watching, but thanks for jumping in. I am further going down this random VTuber trying to understand the I just want to understand these algorithms. I think they're kind of interesting and just want to see how it works. That's what this whole stream is about, and I am currently in the midst of coming up with the first properly generated line in the vector space of this warped thing, this amalgamation of shitty code that I'm writing. I'm pretty sure I have a friend of mine that is a math guy. We'll just call him the math guy because I think he hates being called just the math guy. Pretty sure he's just like crying at his screen right now. He's just like, why? Why are you doing this? It's so terrible. I don't know why this didn't draw anything though. That should have drawn something. We're on Bezier Grid. We're drawing Bezier Grid. We're like, I don't know. This should have drawn something. Let me purge it, and then I will okay, so if I iterate over all the lines that exist in my list of lines here, it should draw them. Blue, blue. So this should work. That's how this worked originally, but I don't know what I broke to make it not draw things. That's confusing. Oh. Oh, did I? Why did that stop working? Okay. Oh, I know what I did. Well, okay, so this almost 30 or 40 minutes ago, now that I think about it, I redid all this loop so the drawing doesn't happen inside the main like the main game loop or whatever. So what's happening here is that I need to fill the screen since I'm just going to draw it one time, it looks like. I'm not going to do that. I'm going to just put it into the loop because I'm already calculating everything else I need up there, so it's fine. It's fine. That's what broke. And whatever. Okay, so that draws the Bezier outline. So let's draw my left and right, or my new line that I generated, and see how horrible it is. So I'll just draw it right down here. This will be the yellow line that should be on the... Fascinating. I have no frame of reference to know if that's wrong. Jesus. I don't have any frame of reference to know that it's wrong. That's terrible. Okay, let's assume, I'm going to assume that it's right, which color me surprised because, you know, did something right the first time. I got a weird, random, spurious print in my game loop. It's this right here. I don't like that junk code being drawn. So let's assume it's right because you'd imagine that it's going to have to get flatter as it goes down this this grid anyway. So if I imagine these horrible things, what I can do in this control area, I need to genericize this and turn it into a function to generate those new Bezier lines from the control points. So I need to figure out how to do that. So that'd be my first step, is like, what do I want out of a function that would generate these new lines? This is hurts the head. Let's see. I was planning on doing this for about 2 hours. I actually probably have I'm already a 145. I actually probably have another hour in me, to be honest. I can probably get through a lot more, just kind of getting an idea what this space looks like, and then what it would take to translate the two-dimensional grid into the warped two-dimensional grid, just to see if I can figure that out. I think I might be answering all the wrong questions here, because I think the end result is that, like, you know, if I have a texture that's on a two-dimensional grid, what I'm not actually going to have the texture on this. I don't care about the texture. What I care about are the control points, the triangles that get drawn. And what I'll be doing is I'll be transliterating those control points into unit vectors for this square. And then when this warping happens, I'll be asking the question more like, hey, where is vertex, 0.25, comma 0.3675, like on this warped grid? Go ahead and then draw that there, and it'll just move the triangles around as necessary. But I think what I think I'm actually going to end up doing is I'm building a lookup tables. What this feels like I'm doing for creating a sort of linear interpolation system from this grid to this grid. So that way, when you do the warp, you'll get your final position. They may actually warp stuff less linearly than I think, now that I've really thought through this a lot more. I don't know. I'll have to look. I'll have to look at how this warping effect is fascinating how it works. And there's just not a lot of extreme examples that I can pick up, and I'm having some trouble with this application, trying to learn it, at the same time. Yeah, I'm not sure. So, all right. I need to make this into a function that generates a new line based on a previous set of lines. So what I want is a function that takes, let's just call this new line. Create new line. Sure, this is utterly abysmal to call it that, but I'll call it that because that's who I am, abysmal. I'm going to need a left line, we'll call this an A line and a B line. And I guess the truth is I just need to know the percentage, like the how far down the line you want the line, which, okay. Oh, no, I need to know, what I actually really want is I want to create new lines, and I need to know the number of segments. That's what I need. Ah, okay. So that will then create, so we get a line A and a line B, and I need to know the number of segments that you have in your line. Yes. Then I will create the line A and line B points like this. So we'll say line A is this, line B is this. No, that's, wait. Oh, I'm saying line, okay. These are, so let me, just to make this is going to be A is an array of Vec2D Bezier, like that. B is going to be same thing, and segments, number of segments. So when I calculate this left points is going to be calculate the Bezier of A, and I'll call this is A points. Let's see, I got so A points, and then I got, this is the equidistant points, and this will be the number of segments. The number of segments, what is that, 5, so it'll be 1 over, so the percentage, we don't need that, I don't think. We will eventually, because I'll need to calculate the percentage, so it'll be 1 over, so 1 over segments. This is then B points, this is B equal points, yes. And then all this mess, and then the new line. So I still need a single function to create a single line. So def create a new line. This is when you don't know what you're coding and you're just crossing your fingers and hoping for the best. We need the EQ points. We need the left. Yeah, we need, I guess we're gonna call this left and right for A and B, I guess. I don't really know what else to, I don't want to rewrite all that random code. And then this also needs this left EQ points. So I need to say left EQ points, and then right EQ points, just so I don't have to regenerate all that stuff. Let's see. All right. I think that's all I need here. Sorry about that. There's a lot of clamber around the house. That's all right. So I'm staring at this. I think this is correct. And all I want to do here is just, now that I've created the new line, I just want to return the new array points here. And I think this is good. Cross my fingers, hoping for the best. So creating a new line. So I want to go, so what I want to do is figure out, like, oh, all I really want to do here is I just want to say what segment it's on, right? Oh, I need to know the percentage because I calculate it, so it's going to be, we'll say segment, and we'll say segments. We'll just send all this good stuff in. And so this will be, this one will be segment over segments. And this will be segments minus segment over segments. Yep. Good enough. This one. This one. Let's see. This guy. So I don't need this percent thing. What I need to do is say for I in range segments minus, no. It'll just be segments. Well, then what I'll do is I'll say, create a new line, and I will say this is going to be the, wait a minute. Oh yeah, I need to, oh weird. Okay, so I need to say, yeah, left P1, C1, C2, then the EQ points. Okay. Yes. Oh, EQ points. This is supposed to be segment. Yeah, which segment do we go down? Yep. That's more like a segment index versus an actual segment. And then, okay, so we'll create an individual. So this is, B, whatever. B, it's a B. Create a new line. This is going to be A EQ points, B EQ points. Then it's going to be the segment. It's going to be I, and then the total number of segments we just pass on through, so we can calculate percentage. And yeah, like this should be a whole bunch of new lines. So lines equals, we'll just do this. Plus equals return lines. It's that easy, guys. What do you, come on, it's piece of cake. Well, that even, okay, it runs, so I still got code that works. All right, let's give this the old nix. Okay, and so this is new line. So now we have a new array of lines to render. Let's call this function and cross my fingers. That's lines. This is new lines. New lines. Left, right, and then I think the number of segments, right? Segments. And right now we've been doing 5, but I'd like to see what this looks like when we increase it. That'll be interesting. So we just take this and yeah, we forward line in new lines, and we get to draw these things. So let's ignore the control points and all that stuff for now. Let's just draw the individual line. Okay, left points is not defined, and that is in create new lines. Oh yeah, right, because I have A points and B points in here. I was trying to refactor it. This is create a new right, equidistant. This is A points here, and this is B points. Oh, I hit Control B. Interesting. All right, right is not defined. Of course it isn't. Create new lines. Yes, this is B. Oh, fascinating. I created new lines that pointed to the same rightmost point, which is, so that's really easy to fix. That's just segment here. Or is it easy to fix? Wait, why didn't that fix it? That's amusing. I blame Terrible. I'm pretty sure it's his fault. Well, okay, the first problem we have is that we're calculating a new line for the 0th one, and they're all going to like, that's strange. Okay, so we don't create new lines for 0. We want to say 1 to segments like this. That's the first step. That's definitely a bug I can fix quickly. The other bug we have that needs to get fixed is going to be, it's somehow picking the same point for the right side destination. So it's going to be generating, so to create a new line, we put the segment, so that we need to have, oh, that could be part of it. I don't think that's it, but that is a bug regardless. Okay, so it's just not looking at the right side coordinates correctly. A and B, B EQ points, B points, B line, B points. So these are all doing the right thing here, it looks like. Boy, that is funny. Line C1, and this is, oh, segment. That's what the problem was. I should have looked there. So these are all generating very straight looking lines. This doesn't look correct to me. As a matter of fact, this looks different than the original line that was generated in my previous iteration. So if I come down here and I resurrect the one that created the new line and I draw just the new line itself, we'll do this one in red, I guess. I don't. Oh, they're all in red. Let's do blue. Yeah, that's strange. It creates a slightly different version that has a bit of a curve down, which is you'd anticipate some curve down, and you'd also anticipate that it's going to have to get flat quite quickly as it crosses the center. So these yellow lines look incorrectly generated. So to kind of understand why they're being incorrectly generated, we have to determine maybe like the percentage number, like maybe this is wrong, the segment over segments. Oh, you know what? This could be because these are not floating points. So this could be a floating point issue. So I could do this. All right, so this is going to be APCT. Okay, we'll take this thing. APCT is going to be this. And then we'll say BPCT is going to be segments minus segment over float segments, something like that. Yes. So this is APCT and this is BPCT. So this is probably this. I think this is pretty close. If this is not it, it's. That should do it, maybe? Let's see. No. As a matter of fact, I feel like they curved up the wrong direction. Maybe I flipped the signs or something. So this would be, so if I did segment over segments, creating a new line, this is going to be 1 over 5, right? So 1 over 5 is going to be 20 or 0.2. That should be correct. And really, it should just be like 1.0 minus APCT for the other one. That's easier to just do now. But it seems like we're working in, like we're flipping the space around by mistake. Like a sign got flipped somewhere. Maybe it's because of the left-right semantic, the way I was doing it. Now, AB is always left-right. This is the way we did it originally. All right. All right. Left EQ segment, right EQ segment, this and then. Yeah, it's really confusing. I don't know what I did wrong here. Let's see. Right, this gets our A length. Oh, this might not be right. I should never have to touch left control point 2. And let's see. I will. Okay, so I should never refer to the left control point because. Sorry, the left control point 2, because that would be. That's this control point. I only need left control point 1. So I think that's what's happening. I don't know, that's weird that I got this error when I calculated it this way and not the other way. That's fascinating. Because I should never really have to reference. Oh no, that's not true. Hold on. Yeah, okay, hold on. Wait, wrong. I have to calculate the new control point for these two interpolated across this line, and the right control points interpolated across the right line. That's not a problem. So maybe the control one, P1, P2, like maybe this is in negative space. A real quick way to do this, I could try this. I could just try flipping the signs. I could do actually here, and let's just see what happens. If that's what's going on, then I suspect that wow, that's really frustrating. It could be I could do no, if this is normalized, it wouldn't matter. This is, let me draw the control points. That might help me kind of understand what's going on. I'm pretty sure they're just above, but I'll do that real quick. These are the control points. Yeah, I don't know why I did that. Okay, and let's draw those in blue. That'll be fine. Oh, yes, because so okay, so it's adding. That's it. So it is showing. I wouldn't expect that to be there. That control point's in a weird spot. That is a very weird spot for it to be, actually. So let me, I'll capture this real quick, and then I did a close. That'll work. So let me capture this, and I'll explain what I should be seeing. Oh, not this, I need that. Why are you not pasting? What did I do to you? There it is. So I'll explain what's happening. So these control points are supposed to be interpolated, and I think what I would anticipate you would get from these control points after being interpolated would be, let me get that a nice, why is it so transparent all of a sudden? Oh, I must have hit something to make it transparent. Oh, I'll take it. So this is the control point I'm getting, and you would expect the control point to be a blend between these two, this vector shape here. So it would be, and I'm probably saying this more from my help than yours, to be totally honest. So I would expect it to be this this shape, and I would expect it to be somewhat close, but it's probably going to be slightly rotated or quite aggressively, because this is aggressive fall off. So you'd expect it to be around about the same length, because the length shouldn't change, because neither one of their lengths have changed. So what you'd kind of expect to see would be a rotation here. So let's say that did I group these? I did. So you'd expect to see a bit of a rotation that would be kind of like this, I guess. Oh, geez, wow. Oh, that's so wrong. Okay, yeah, no. You wouldn't want, oh, this is, my brain hurts. I want to copy these control points. I want the bottom control points. Oh, I am, okay. I don't know. I'm getting lost. Let me double check what my math is actually saying it's doing. What I'm saying is I want my left and right control points. I want to calculate the A, which is 80% of left control point. So I want 80% of this one's, this vector. So, right, so I'm calculating 80% of this vector. And if I go here, what I would expect to see is this vector kind of copied and rotated like this. And then here I would see a little bit more of this, you know, it would be a little flatter like this. But that's only if we're drawing vertical lines. We're drawing horizontal lines. This control point is not the right control point, especially since these control points aren't shared through the life of the this grid. I need to fade between the control points of the top and bottom, not the left and right. I need the left and right control points to generate the steps for the left and right curves. Wow. So I'm going to exaggerate the top curved line to kind of illustrate what I mean by that. So on the top line, let's move over 200 pixels, and we'll move this over to inward 200 pixels, and I will regenerate the... All right, so I changed the control points up here. So this control point is actually the ones that we want to copy for the next line going down, and I would be merging them. I would be slowly interpolating them to the control points for the bottom line, not the left and right. I don't know why I ever thought I needed the left and right like that, but that's okay. Mistakes are made. So I need the left and right lines here. I need the left and right equal points. But I also need the top and bottom points, top and bottom lines. So I don't need the control points. I need the left. Why am I calculating left P1? Do I need a left P1? No, because I need to copy and merge. I need to blend the, okay. My brain hurts. There's a lot of numbers to keep track of. So I don't need these control points for anything influencing these lines. So I'll just, I don't know. Because we already have the left and right EQ points, so I even need the left and right variables here? I probably don't. I probably don't need left and right at all. I probably only need top and bottom and then the left-right EQ points, because that's what I walked down. This is making a lot more sense now. So top... we're not going to rename those for now. Yeah, I kind of thought that something would blow up. It's because I don't have this stuff written. It's not doing the right thing here. So create a line. We don't need A anymore, and we don't need B. We need... This is going to be left line. This is going to be the right line. I'm just going to keep the semantics because, and this is going to be left points, left EQ points. This is left points, oop, nope, right. And this is going to be left EQ points, right EQ points. And then this is the segment we're on. So then I need the top line. So this needs to be set in. So I need top in bottom, and I need to put top, bottom in here, and then when I call create new lines, bottom segment, and then create new lines, left, right, and then in top lines 1, bottom lines 3. Right, top, bottom. All right, I think we're getting somewhere. This may be closer. It's so weird that this is egregiously off. Like these calculations aren't right. It's hard to isolate some of this stuff. I'm not sure how to isolate this code a little better, so I can kind of, you know, sandbox like 1/10 of an equation instead of like, you know, the entire algorithm. It makes it a little difficult. I don't know why the right side got so confused. 0, 1, 2, 3, 0, 1, 2, 3, top, bottom, right. P1, 2, left, C1. I could try to make a, I guess I could normalize, I could create a function to normalize 2 vectors. That way I can get an idea, like I can separate that out just to make sure that the math is right there. So let's say that I want a vector that's 80% one and 20% another kind of thing. This should be right. Okay, I'm assuming. Okay, let me do that. Let's do that real quick. That'll. So what I mean by this is I need 4 points. I see a def, average, AVG vector. Maybe I'm not doing the average of a vector right. So P1, right, P2, and then I have, this would be AP1, AP2, and BP1, BP2. So I also need to know the percentage, the blend percentage. We'll call it blend. So in this situation, I want to say, I'm not going to worry about the position of this vector. It's going to be the absolute value of the vector. It's going to be the, so it's going to be AP2. So I need L1 equals AP2 minus AP1. And this is going to be my length. And then I want to take the blend percentage, so I want to multiply blend, just in case that comes in as an integer. Let's call it a float. And then if I get, so I get L1, so, and then I also need, I guess I need L2. Right, so this is L2, and I need the A blend, the opposite, whatever, the other inverse blend, I don't know, 1.0 minus blend. Right, so, oh, I don't divide by 2 if I already multiply. Oh yeah, these are already normalized, so these should just be added. I think that's where the mistake was made in the other code. So my new vector's length is this. So L is equal to this. And my vector itself, I need to take, again, AP2, this is BP2, BP2, BP1. I need to then say the actual resultant vector is going to be, or this is the length portion of the vector. I need to keep track of the I guess the angle or whatever of the vector component. I think that's going to be AP2 minus AP1, right? We'll start there. We'll just zero out this. Now this is a vector that's relative to the AP1 to AP2 line segment. And then I'm going to dot normalized on this, and then I'm going to do the same thing to BP2, BP1 normalized. Then I'm going to multiply this times the blend, and then I'm going to multiply this times the A blend. Oh, A blend. I guess I would just, again, add these two together. Yeah, and then I would multiply this times the length, so return V times L. And this would be the average vector of 2. And I think this is where I'm breaking down in some of this stuff here. Now, I can now test this a little bit. Like, let's just make some assumptions and go test them, right? So let me kill the Bezier grid. Let's make sure that this average vector amalgamation of horribleness is actually what it is, what it purports to be. And we get sanity out of it. So it's vec2ds. So vec2d, and then a blend percent. We'll say 50%. Just get numbers that you know. Let's just start with a sanity check. 10, 10, and this is 10, 10 to 100 by 100. Let's make this line go straight to the right. So this is 20 times 10, right? So this is vector goes straight off to the right. This one is a vector that starts at 10 as well, but it's on the 20th, and it also goes, the x goes to 20, and it's also in line. So this one also goes straight off to the right. If I were to blend these two 50-50, I would expect the vector output to more or less match, like, you know, whatever this vector would be like. So I would say you would expect it to be vec2d of minus this, right? So let's assert that to some degree. Invalid syntax. Is that not right? What did I do wrong there? 2.5. Oh, commas. Can't assign to literal. What did I do wrong here? Right. Okay, so you look at this, it looks like it comes back. Oh, that's dangerous. I just realized something. These vec2ds, they don't up to floating point when you construct them. So I will actually force that in this vec2d library, because that's could run into weird problems. Okay. That could break a lot of stuff if I wasn't paying attention. Oh, Python and your weird floating point strangeness. So okay, yeah. Let's write some other vectors here. Oh, not in this piece of code. I'll scroll over the bottom of that for no reason. So the reason this works, why I would expect this to be like that, is I'm literally just taking 50% of this. They're the same vectors, right? So if I took 10% of one and 90% of the other, I would expect these to all be, no matter what percentage I put here, I expect the vector to come back and be literally the same numbers. Where it gets strange is when we have, let's say we have 1010 going to 2010, but let's go from 1010 to 2020, and we blend this. What I would expect is, because this is going, let's go here. we are drawing, I need to start copying this circle from everything. I've got a circle here. See, we're going straight out, so we're going some unit. Let's say this is our grid, that's 10, 10. Then I'm going one more out, so that's 20, 20. So that's 10, 10, 20, 20. But I'm going down 10 units, which would be about that. Right? Yeah, so I'm going basically at a 45-degree angle. The other vector that we're blending is one that goes straight out, and it goes from 10, 10, 20. Yeah, it's lower on the, but it doesn't matter. It just goes straight to the right, 10 units. Now, this one isn't actually a 10 length unit. I would expect this to be, this is, you know, square root of 1. It's going to be 1.141, whatever, the 141, etc. But averaged with this, so I would expect the vector length to be different. So let's also we'll say v is equal to average vector, and I would print v.length and v. We'll print the vector first. Oops. So the vector length is 13. I don't know if I would have expected it to be 13. So let's calculate out what that would have, what it should be. Oh, maybe I wanted 10%. Maybe yeah, it's a little different if you do it the other way around. Oh no, that's even weirder because oh no, it's not, because this is saying I want 10% of the first vector length. So that first vector length is going to be vec2d 10 10. And we're going to say this one here. We're going to say minus this. And we'll get the length. So we get 14. This feels like that's working. I mean, not a lot of testing going on here, but you know, it feels close. So I'm getting the length here, and I want 10% of this length. Oh, that's another thing I'm doing wrong. I want 90% of the first one and 10% of the last one. I got these numbers flipped around on the old create line thing here. Because in this one, when I say segment I, I'm saying I want segment, I basically want to flop these over. I want this to be B% and this to be A%. And that to be B%. That is definitely a small glitch. That would definitely cause weirdness. It would make the lines point in the wrong direction as well. Okay, let's keep looking and verifying this this average vector thing. So then we do, I would expect that, and then I would also expect that this is a length of 10, so that's 2020 minus 1020, so this is the length of 10. Yeah, length of 10. And I guess then, assuming all that, I would expect the length to be times 0.80. Ooh. It's weird because my average vector, this function feels correct to say I want 10% of A and 80% of B, but that's backwards from the logic in the other function. It's just like kind of a like, which do I go with this? I don't really have the interest in trying to vet this. Not gonna lie. I'm just gonna assume this works, and I'm also gonna use it in the backwards way. I'm good with that. It's okay. That's how life works sometimes. You just take it on faith, right? That's how you program. It's all faith. So now I'm going to incorporate that into the average thing, into my little shitty sandboxy spot here. And I don't need these left points. What I need is top, bottom. Oh, top. What? Yeah, these are all tops. That should be, and then I'm going to stop drawing all of these lines. I'm just going to draw the one single line. Oh, I broke something. Circle blue. Yes, B points. No. Int A for A, NP. What? 209. Oh, I put that in the wrong place. Okay. Helps to read the error message. Int A for A, NP. Okay, so this is my wonky new line being created incorrectly, but we're working on it. Okay, so I have my left points and the left EQ points, and I'll never need to look at left or right points ever again. I only ever need the left and right EQ points. Okay, so then what I want to do now is I want to say the average vector of my top I want the top left line segment and the bottom left line segment. That's what I want. So I want top 0, top 1. That's the control point for 1, or the control vector. And then I want bottom 0, bottom 1. And I want to get 80% of A, and whatever's left is B. So that should be correct. So this is the new V, this is a new vector. And what I need to do is then add this. This is added to left EQ points 1. And this gives me my P1 for the line. No, this gives me C1 for the line. Yes. So that's C1, and then C2 is going to be, well, real simple. It's going to be the top control lines. It's going to be top 3 to top 2, bottom 3 to bottom 2, 80% plus right EQ points 1. And then that is that, and then the new line is C1, C2, and it doesn't look like I need any of this stuff anymore. Well, that got simplified real easy. Oh, that's it. That's got to be it. Oh, well, that feels good. That's the one. Okay, so all right, okay, let's move that code into the right locations. So we want to create lines. We can drop all of this stuff right into there, basically. We want that percentage calculation. That's the right one. And create a new line. And the create a new line will be taking, oh, I just yeah, a PCT or just PCT, and it'll do the mixing itself. It'll do all the other. I actually want seg. I'll just do the 1.0. 1.0 minus this bad boy. Let's see. Yep. And so this will be PCT. Right EQ points, and then the new line will just be the left EQ points. 1, C1, right EQ points. I don't need to calculate this or this or this because I'm calculating it in the other function. That's awesome because wow, that got small. This may be enough to do it right, and so now I can kill out. Oh, they're all being drawn to the same line. Love that. Best thing ever. What did I do? I probably had a constant somewhere in here. I do have that constant. Ah, that's a segment. Kind of the same mistake I made earlier. Right EQ points. This looks, nope. This needs to be left and right EQ points. Segment. Oh, look at that. The blue line draws over the yellow line. So that's it. That's the freaking stretched and curved. Whew. And it's drawing control points. The control points are interesting. They don't. I guess they are all equal length, though. Well, no, I guess that's not true because this line is longer now. But it does blend. So now I can generate the blended space for that thing. I need to iterate over. I need to test an assumption I have, but if this is drawn correctly, this curve iterates correctly, and this is a properly smooth linear interpolation of these, then my assumption is if I take this point and I go in, 100 length, or I guess I go 25% down this line. If I also go 25% down this line, if I draw the curves this way, they should match up. Like I feel like those points should be the same. So I gotta see if that happens. I'm curious, and the way I would do that is I'm going to drop this calculation here. This one, no more new line. That's this thing down here. But I am going to create. So I am going to create the. I'm going to swap the left and right and the top and bottom. So I'm going to say let's draw from top to bottom, right? And then go left to right. And so now this will give us another set of lines that go vertically. And they look like they match. I mean, this feels like they match the right perspective of what's happening. This looks correct. Oh. So now I got to figure out how I'm going to create a linearly interpolated space of points across this. Jesus, what did I put myself into? Well, we're right at 2.5 hours. I think I can keep the next 30 minutes, and then I'll probably have to end it at that point, so I can maybe cook up some late dinner. Yeah, this is looking good. I want to drop the control points so I can just see what it looks like. So I'll do that by putting a little conditional in here. Oh, wait, that's the wrong. Wait a minute. Point in points. Point in points. Points. What is points? Is that the... Oh, this is my equidistant points. I want those. This is the control points right here. show controls. And then that needs to be down here. Well, I don't know. That's looking about right. That really has a good. I like that shape too. It has a. It looks like the inside of a torus. Like it looks like it just spans the inner sphere of a torus. Like I like it. Okay, so I want to calculate my first set of lines. So this is line. This is new line 1, 2, 3. Or this is new line 0, 1, 2, 3, 4. So 0 and 4. I want to calculate their equidistant, or maybe I could just do this here. I could do the. Yeah, on these lines here, I can calculate their equidistant points and draw a circle. I want to split the lines up. Let's, instead of making, let's do this. This will be horiz lines, and this will be vert lines. Vert lines. And I will say horiz line, or new lines. This is horiz line, horiz lines. And I'll just draw them multiple times or something, different colors, just to kind of separate up these. So, okay, PN lines, draw a circle blue. So yeah, this will just do. And we're getting the green dots, you know, somewhere on equidistant points on the lines. And then the same thing, and this is dividing the line up into 5 equal segments. And so I think this should be correct. If I drop, like if I drop the vertical lines in there, they should intersect on those green dots. And if they don't, then I have to reconsider what I'm doing somewhat. So let's hope that that's what's happening. This thing. Is that just vert lines? Yeah, it's vert lines. Black. Do I have a black color? I don't. Look at that. It's they're slightly off though. I don't know if that's just the errors that's inherent to the process that I'm doing, or if that's an error in the assumptions of the math overall. Like if I get better algorithms to generate some of this stuff, that little bit of error might go away. I kind of want to see. I want to be able to move these points. I just don't want to build a UI in Pygame. And there's no. I don't think there's a really easy just one and done download Pygame UI that just works out of the box. That's always been an annoyance of mine. I guess I could do something really shitty. I could do really shitty UI real quick. Let's see. 10 minutes. I might get a little. I might go a little. Might go slightly more into overtime, but I think I can do something. All I really need to do is draw a couple of boxes and then def like, you know. Well, I know what I'm doing. Class slider. So I just want slider controls. Like that's all I want. I need to be able to render it. So let's do a render. I need a screen to render it to, or I can just use the global screen, or do I have a global? I do not. So I need a screen to draw it to. What the render is going to do, I need a definite. I'm just going to assume all sliders start out at 0.5, value equals 0.5. That's going to be self. Oh yeah, got to do the Python thing. Self everywhere. And I think tomorrow I will pick up the stream as well, but I spend some of the day tomorrow moving this into React and trying to get some like an HTML renderer kind of going, so I can start binding this into Babylon JS, so I can actually we can actually start seeing a warping of sprites. So, I just all I want to do. Oh, I need a position. So let's do pause. So this is what we call a shitty slider. I am not going to do anything sophisticated. I'm going to draw a rectangle. Draw dot rect. Draw a rectangle. What does a rectangle take? It does take a rec. Like this. So that is going to be. So I need self dot pause equals pause. And so I want to down here in Bezier Grid, I want to create a slider. So I want to say like x slider equals slider, and it's going to be a position vec2d of 0, 0, like that. I don't think I give it any other arguments. Nope, just the position. Okay, and all rectangles are all sliders are just going to be 100 pixels wide. So so this is going to be rect. I probably don't have import local star. Oh, that's beautiful. Also, why Pygame? Why did you do this? This is so annoying. I'll get off my soapbox real quick. They show some kind of weird tag if you don't throw this crap in there. It's like, why is there a nag for Pygame? It's like, no, go away. That's abysmal. Utterly abysmal. That's honestly why I'm really just stoked to move this into React and just go into the JavaScript side of things. Okay. Yep, I need to create a rect surface. So I need a rect. Oh, I could be even more ridiculous about this. It's never allowed to move once you create it. Self dot rect equals rect. I think I can just provide, like I can do pause that like dot x, pause dot y, pause dot x plus 100, pause dot y plus say 16 pixels is probably a little big, but it's fine. And then when I render, I just say pygame dot draw dot rect surface, color will be black. Is it a fill rect? Is this a fill rect? If width is 0, fill the rectangle. Okay, so it needs to be oh, interesting. There's like a bunch of other arguments that you can pass to it. So this is going to be self.rect, self.rect, and then I can do named width equals 0, and then I can also do, there's a border radius, but what would the color for the border be? Whatever, I'll just draw a second rectangle. Okay, so there's this one. So that's black on the inside. We will, I don't know, throw like the gray. No, it's already gray. I don't know. We'll just maybe not even worry about it. So there we go. Like this. All right, so down here, Bezier Grid, running sandbox. I got a slider here. This is the X slider, so after I draw everything else, I go ahead and say x slider.render screen. So this should render a slider. Or break, one or the other. Right, that needs to be self.screen or screen or something like that. Takes no keyword arguments. Oh, this might be a newer version. Yeah, this might be since I'm running Pygame 2 on Python 2 or some older version, it might not have that. That's good enough, like, you know. And so like the idea is like I'll set that up so if I click anything, okay, and then def update self dot pause. Yeah, that's fine. And then this will be the mouse position, and I'll only send this update if the mouse is clicked. Let's see. So all I need to do is basically say, since I have I'm actually putting the absolute positions in this rect, I just need to say if self.rect, I think there's like a contains or intersects. Move, inflate, union, fit, normalize, contains. Collide point. What a silly name for a function. Okay, so return sphere if the given point is inside the rectangle. Perfect. So all I need to do is say if rect dot collide point pause boom print booyah. Also, print isn't a function in Python 2. So right now nothing will happen because I don't have it in the event loop. So I need to come down here. There's some event loop stuff. This is if wow, this thing actually has a selection thing. That's interesting. Okay, so mouse button down and event button equals 1. Yeah, so this basically only get triggered on clicking, so that's whatever, I guess. The okay, while running, here's my events. So LF event type mouse button down, event button is 1, P in control points. I say event.pause. This is this thing. And so we just basically say x slider.update. Like this. Oh. Oh, that's weird that it didn't crash. Oh, I didn't click anything. Right. Argument must contain 2 numbers. Okay, so update. Oh. Wait a minute. What is this even? Is it just event.pause? It's probably just event.pause. Oh, cool. There it goes. So that's why. So I click it. I can set something. Okay, and then I wonder if there's a way to just trigger mouse down, and then I can just, if the mouse is down, just always update all the sliders. then I can have sort of interactive scrolling with it. That would look pretty good. Let's see. Let's just do that. Okay, I need to render the control node that goes inside the slider because you can't update a value if I can't see it. So I'll just do another rectangle. We'll make this one green. And we'll say that this is going to be r is equal to rect, and it's going to be self.value times 100. So we get the value is 0.5. So it's set to half right now, and then yeah, that's fine, I guess. I don't. Oh, maybe I want it to be 0, and then it goes from -1 to +1. That makes way more sense in my head now. So I will set the. So if I render it, I take the value times 50, and I'm going to say that that's going to be this pos.x plus self.value, comma, pos.y minus 5 pixels, comma, x is going to be pos.x plus this, let's see, cursor, and I want to, it needs to be not floating point, so I need to say int of this. I'm going to say -5, so it'll be 5 pixels left, it'll be up 5, it'll be, is rect width and height or positions? I can't remember. I'm assuming it was absolute. Oh no, it's width and height. Oh, okay, so this is supposed to be 116. Yeah, okay, that makes this area a little easier. All I was going to do is make this 10 pixels tall, and then if my little widget is 16 pixels tall, I want to make this 16 plus 10. That's pretty big, but okay. -5. Yeah, that should do it. And that's going to be pos.x plus cursor -5. That should be good enough. And something's not right. Okay, pos.x, that's self.pos.x. It's drawn at the far left, so that would, okay, hold on. Oh, I didn't 0 the cursor itself. It needs to be, it's going to be self.value times 50 plus 50. Done. Okay, cool. Slider. Let's move it into a more logical location. It's down here. Eek. Nice. Okay, so if I click it, I get an answer, I get a response, but it doesn't do anything yet, so I now need to update it. So what I need to do is I need to say, I think the rect has a thing called the top left, rect.top left. Yeah, .top, it's lowercase, top left. That's a point. And so I suspect I can just do, so pos, so it's going to be top left, so it's going to be self.rect.top left. So it's pos minus this. So this is now my absolute position of the mouse cursor within the rectangle area. And since I now know that position, I can then take that position and I can subtract 50 from it and divide by 50. And that'll give me my negative. Yeah. Yes. I take the x, then I subtract 50 and then divide by 50. And set the value. And hope for the best. Oh, that was not the best. Oh, tuple and tuple. Okay. Oh, it won't. Okay. I wonder if I can initialize a vec2d from these. That would be amazing. Oh, no. Oh, vec2. No, it is vec2d. Oh, I just mistyped it here. Okay. That definitely is not the right answer. Oh, right. Wait, okay, so I collide point, and then really I just want to take the top left. Yeah, the top left is 10, 10, and I just want to say top left dot x minus or pos. Wait a minute. If I did top left plus 50, right? Then minus. If pos was, I do pos minus this, pos dot x, or pos 0. Yeah. And this is also 0. Well, that's a weird range. It goes from 52 to 144. How about I just calculate the exact... Let's just do this. What am I getting out of this? Oops. 3 to 96. 95. Yeah. I mean, it's basically what I would expect to get. Divided by 50. Oh, 0.0. Right, 1.9, 0.4. So if I just subtract 1.0, that shouldn't have taken so damn long. Yeah, there you go. 1 to 1. Whew. Self.value equals this thing. And so now it should start drawing it when I click it. Oh, look at that. Nice. Boy, I really do want the mouse to be able to slide it as I drag around here, but whatever. So I want to bind like I kind of want to bind like one of the control points to something. I mean, that would be interesting, right? Like to be able to warp this from... Yeah, there's a lot that I would like to see. I would like to see this animated, I think, is really just all I want. So maybe I don't care about the slider I just spent 10 minutes, 15 minutes doing. Maybe I just want to move the line manually. So like we have these lines and the control points, say for the right top line, I can move it. So we can say right top center. So RTC is going to be lines 2, and I want the second control point. And then I want, while I'm in here, oh, I can't, I can't move these things because none of this is it's not being dynamically generated. It's being generated statically. So if I just move this into here, I wonder how poorly performing this is. unbound local variable lines referenced before assignment. That's this one right here. Okay, so now everything's being generated in real time. And I just want to modify one of these variables is really what I'm trying to do. So that means RTC can just be a constant for now. I can just say it's a vec2d of 400 by 150. And then I want to calculate it. So I'm going to put this here. I'm going to say this is RTC plus offset and whatever offset is calculated. And I'm going to calculate offset by on every frame, or do we get a clock? So I can say, how does this Pygame clock thing work again? So the Pygame clock, it should give me like a floating point value for, you know, some amount of time that has passed. That's my assumption. Okay. Let me look for this reference. I can do, let's see. Okay, clock tick. Somehow I have, okay, so I have clock tick down here was like 100 FPS is what I was specifying. And this returns back, I probably don't need that down here. Oh, did I just, oh, it doesn't matter. Lost it already. I think you get MS here. And I want to say that OFS is equal to vec2d of sine of the angle. The angle will be milliseconds. It'll be, I want to move, how many times I want to move around this in a second. It's fine. I'll leave that as milliseconds for now. And then cosine, right? And then milliseconds. Now I want to think of the vector distance that I want to make this thing go. So I want to say 25. So this will rotate around in a radius of 25 pixels around that center point. Added over here to RTC. I think this will work. No. Oh, math. Okay. Do I have to import math for sine and cosine? Okay. That's really fast, but it looks cool. This makes me think that my like really shitty like algorithm that I came up with, it's horrifically not performant. It's not that bad for just an initial run. Like it'll be good enough. So let's divide this by like 50. I don't know. Like see if this slows it down a bit. Maybe a bit too much. Maybe this would be like 10 revolutions per second. Oh no, it's 10.0. Maybe I want to multiply that? No, maybe I want to go back to 50 or 60. I probably want to just show controls too, because that'll help me see what's, oh, talls. That's not true. Okay, so you can see this control point here jittering, and you can see all the control points that share it also jitter, which is nice, which definitely makes me think that's doing the right things. Okay, so it's definitely not doing the right thing. Math.sine, math cosine, that's my period. Oh, it's because, okay, it's because I'm in radians. I have to really scale that up. I just realized. it doesn't really seem to be... It really doesn't act like it's rotating much, does it? Like, I would expect that point to be kind of all over the damn place. What am I doing wrong here? This is silly. Okay, I'm just gonna count the frames. Oh, I'm an idiot. I know what's going on. This is not absolute time. It's... Oh, Jesus. It's not wall clock times. It's yeah. It's the time since the last frame. So there's a Pygame function for getting the current time. So I can say time is there, t equals get ticks. And then that's what this needs to be. It needs to be t. Jesus. There we go. So now it's rotating around an oval on that control point, and we're seeing it warp and twist the field underneath of it. That feels good. I like seeing that. Okay, so I also want to... I just want to move it in a circle, and so I'll drop that, and I'll move that here. It's 200. But I actually kind of almost want to just make it do something really egregious, like move it around that 500 by 100 point, and then make it so it has a 200. It's gonna be like an egregiously like crazy over the top warp. Yeah. Oh, look at that. That's gorgeous. But yeah, I was worried about that. Whatever I'm generating for this space, this curve, is not, the points don't line up the way I would sort of like them to. So that means I probably have some other, I have to consider some other thing when I'm generating this, the control points for the Beziers. Oh well, I think that's a good place to stop. I'm kind of happy with that. Like, you know, it's took a while to get to where I feel like everything makes sense and it's supposed to be about right. But I think I'll try to port the algorithms, like I said, into React, and that way I can build a little UI to kind of mess with the parameters, and it might be a little quicker to iterate in that. But yeah, thanks for watching. I'm glad everybody that stayed. And I will maybe see some of you tomorrow.